Weight Shift Control 10-1 Airport TRAFC Patterns. Airports play a crucial role in facilitating aircraft traffic, serving as the starting and ending points for every flight. According to Title 14 of the Code of Federal Regulations Section 1.1, an airport is defined as an area of land or water intended for the landing and takeoff of aircraft. Distinct from automobiles, aircraft can only be slowed down, leading to the establishment of specific traffic rules, procedures, and patterns for various airports to ensure safe and efficient air traffic flow. These traffic patterns, according to airport characteristics, include routes for takeoffs, departures, arrivals, and landings. The specific nature of each airport traffic pattern considers factors like the runway in use, wind conditions, obstacles, and other relevant elements. The operations at airports fall into two main categories: uncontrolled airports, lacking a control tower, and controlled airports, equipped with a control tower and air traffic controller. The importance of understanding rules and operating procedures is emphasized for pilots using different types of airports, grounded in logic, common sense, and courtesy to maintain safety and efficiency. Airports are classified into uncontrolled and controlled, and pilots must familiarize themselves with the specific rules applicable to the airport they are using. Regardless of the type of airport, pilots are always responsible for see and avoid, and must remain vigilant in both controlled and uncontrolled airspace. The concept of standard airport traffic patterns is introduced to ensure orderly air traffic flow into and out of an airport. Factors such as the direction and placement of the pattern, altitude to be flown, and procedures for entering and leaving the pattern are considered. The standard rectangular traffic pattern serves as a foundational guide, including terms like departure leg, crosswind leg, downwind leg, base leg, final approach, and upwind leg. In uncontrolled airports, pilots need to determine the direction of the traffic pattern, comply with traffic rules, and display courtesy to other pilots. At towered airports, pilots receive instructions from air traffic controllers regarding pattern entry and departure. While the standard rectangular traffic pattern serves as a foundation, variations may occur based on specific instructions from the control tower, with jets or heavy aircraft often following wider patterns. The discussion emphasizes the importance of maintaining constant vigilance near airports, regardless of apparent light air traffic. The objective is to establish consistent intervals for both faster and slower aircraft in the pattern. The concept of a tight pattern, or inside pattern, is introduced, illustrating how slower weight shift control aircraft can fly a tighter pattern than faster aircraft to maintain the same interval. Entering the traffic pattern at an uncontrolled airport requires listening to the common traffic advisory frequency, observing other aircraft, and conforming to the existing traffic pattern. Traffic indicators, wind indicators, and L-shaped traffic pattern indicators are valuable tools for determining runway usage and traffic pattern direction. This comprehensive overview covers airport operations, traffic patterns, and considerations for pilots in both uncontrolled and controlled airports. Patterns at airports are typically left-handed unless otherwise specified. On sectional aeronautical charts, a right-hand pattern is indicated along with airport information. This visual illustrates a segmented circle providing traffic patterns to avoid air traffic over specific areas, minimizing potential hazards. Approaching an uncontrolled airport for landing involves monitoring the CTAF frequency to identify the active runway. When entering the traffic pattern, pilots should use a 45 degrees angle to the downwind leg, heading toward a point abeam of the midpoint of the intended landing runway. Aircraft should be at the proper traffic pattern altitude before entering, avoiding pattern entries while descending to prevent collision hazards. The entry leg's length should allow for a clear view of the entire traffic pattern, providing ample time for planning the intended path and landing approach. The downwind leg is flown parallel to the landing runway but in the opposite direction. For slower weight shift control aircraft, it should be approximately 1/4 to 1/2 mile from the landing runway at the specified traffic pattern altitude. Before landing, checks should be completed, and altitude should be maintained until abeam the approach end of the runway. The downwind leg extends past this point to approximately 45 degrees from the approach end, where a medium bank turn is made onto the base leg. The base leg serves as a transition between the downwind leg and the final approach leg. It is established at a sufficient distance from the approach end to allow a gradual descent. While on the base leg, pilots must ensure no collision risk with aircraft on final approach, especially considering weight shift control aircraft flying tighter patterns. The final approach leg is a descending flight path from the base to final turn to the point of touchdown. Pilots must exercise sharp judgment and precise procedures to control airspeed and descent accurately. As per 14 CFR Part 91, aircraft on final approach have the right of way. When two or more aircraft are approaching an airport for landing, the lower altitude aircraft has the right of way, emphasizing safety and adherence to established rules. For departure, the rectangular pattern's departure leg is a straight course aligned with the takeoff runway. Pilots continue climbing straight ahead and initiate a turn to the crosswind leg within 300 feet of pattern altitude. The upwind leg is parallel to the landing runway in the same direction as the intended landing. It extends past the departure end of the runway, and a 90 degrees turn is made onto the crosswind leg. The crosswind leg is horizontally perpendicular to the extended centerline of the takeoff runway, entered with a 90 degrees turn from the upwind or departure leg. Aircraft proceed to the downwind leg position. In most cases, takeoffs are made into the wind, requiring a slight turn into the wind while on the crosswind leg to maintain a ground track perpendicular to the runway centerline extension. The upwind leg also serves as a transitional part during final approach and go-around initiation, allowing a climb attitude to be established. This comprehensive explanation covers the intricacies of airport traffic patterns, emphasizing safety, right-of-way rules, and proper procedures for both arriving and departing aircraft. In summary, airport patterns are crucial for organizing air traffic flows at airports. These patterns are established based on local conditions, determining the direction, placement, altitude, and procedures for entering and leaving the pattern. The legs of an airport pattern from takeoff include the departure leg, crosswind leg, downwind leg, base leg, and final leg. Pilots need to conduct pre-flight research to identify possible runways and patterns at intended airports. Determining the actual pattern at the airport involves observation, communication with other pilots on the common traffic advisory frequency, or consideration of wind direction if no other pilots are present. Unless indicated otherwise, normal airport patterns are left-handed.